So in this video, I wanted to go over some examples, but specifically examples that deal with our power of a product property or law of exponents. So you can see I have 3 examples up here, and this actually includes the power of powers property that we looked at in the previous lesson, as well as a little bit here today as well, but mostly you can see we're going over examples like that. Now, when I'm looking at this, I'll start with this one all the way over here on the left. 7w to the 7th, all to the 3rd power. You really want to focus on the parentheses and pay attention to where those are, because those will show you what you are actually doing in this case. Now, the 3 up here is going to get applied to each piece inside, meaning each number and each variable. That means that 7 is going to be 7 is going to get cubed, as well as the w to the 7th needs to get cubed. And this is all still being multiplied. So we're going to look at this separately. Another thing in the lesson that we're looking at is, how do I know something is in simplest form? And I gave you 3 things to really focus on with that as well. Make sure that your base only appears once. Make sure there are no more power of powers, so make sure there's nothing like we see here with this w. And if you have fractions, make sure they're in simplest form, completely reduced. So in this case, I would definitely want to continue on, because w and 7 are my bases, and I only have one of those, but the w has some power of powers going on. And also the 7 cubed needs to be changed as well. So let's start with that. 7 to the 3rd power gives me 343. That's 7 times 7 times 7. Now w to the 7th to the 3rd power is a power of powers property, meaning we can take our powers and multiply them together. So this becomes 343 times w to the 21st power, because it's 7 times 3. We're not adding them because they're right next to each other. There's no base in between the exponents, so we're multiplying them. Now I will check to see, okay, am I done? Is this in simplest form? Have I simplified completely? Those are all questions you might ask. Well, I only have one base here of w. There's no more power of powers. All my fractions are simplified because I don't have any, so I'd be done. So this would be my final answer here. There's nothing else I can do. All right, now the next one, we have a few more things going on, but because the 4, my exponent of 4 is on the outside of these parentheses, that means that everything inside, each base gets applied to the 4. So it's going to be 5 to the 4th, it's going to be g to the 8th to the 4th, and it's going to be k to the 12th to the 4th as well. Now I'm just going to take it piece by piece. It looks like a lot of writing and there's all these little things and details. Take it piece by piece, so one thing at a time. First product, 5 to the 4th. Well, 5 to the 4th means 5 times 5 times 5 times 5. So when we do that, we get 625. All right, so that's done. Now let's go to the next piece, the term with g. So g to the 8th to the 4th. There's no base in between the 8 and the 4. That means I multiply them using the power of power property. So that gives me g to the 32nd. Same thing with the k. No base in between the 12 and the 4, so 12 times 4 is 48. So it would be k to the 48th power. These are all questions you want to continue to ask yourself. So because I have no more base to apply that power to, because I just have variables and I've done what I need to with my numbers, I'm done with that problem. All right, last one, 0.5 k to the 5th to the 2nd power. This one looks a little bit more challenging, maybe a little bit more, maybe a little different with the decimal, but you still do the same steps. So the 2 is being applied to the number and to the variable inside. So it's 0.5 squared times k to the 5th squared. So it's going to be 0.5 squared. And again, that might look a little odd, or maybe that might be something you can't do in your head, and that's okay. But think about what the squared term means. It just means to multiply the base by itself 2 times. So it's going to be 0.5 times 0.5. That gives you 0.25. And then deal with the k. There's no base between the exponents, so we're multiplying And that gives me 10. 5 times 2 is 10. So that would be my final answer for that one, completely simplified. And that would be finished for that problem. Just keep that in mind as you're going through these to really look at each example. Make sure you apply that outside exponent to each term or each piece inside. And when you have exponents next to each other without a base in between, make sure you're multiplying them and not adding them. If you're trying to determine simplest form, you want to make sure you check all those things. Do I have a fraction? Okay, check to be making sure if it's simplified, and so on. So let's say I had a problem. I'm going to just give you a few examples here on checking for simplest form. So let's say I had a problem like this. (14y squared x to the fourth y to the third). Okay, no fractions, no power of powers. You know, everything has been distributed inside if it needed to be. But I do have a base that appears more than once. I have y's that appear more than once. Now, I'm not asking you to actually simplify these or take them any step further, but you do want to look at, well, do I have this in simplest form? In this case, the answer would be no. Okay. How about a problem like this? I have a fraction, I have an exponent, no bases are duplicated, right? All of them are only appearing once, no power powers, but I do have a fraction that I need to check. 3/6 is actually not simplified, it's not reduced, so that means that this one would not be in simplest form. Okay, so that's an example of something that would not have a simplified fraction. Let's do one more. Let's say we had a problem like this. Okay, now I only each base only appears once. I have no fractions, but my x is not simplified because I have a power raised to another power that needs to be dealt with. So I'd have to figure that out first. So this would be also no, not simplified. So those are some examples of how you would go through and check your expressions to see if they're simplified or not. And as you can tell, all the problems that we did, we continued on until they were simplified. So those give you some examples of what problems or answers look like when they are simplified. So make sure you kind of look through those, be able to distinguish from those. You're going to be doing that a little bit as well. So there is your examples for this lesson. If you have any questions, make sure you come and see me in office hours or contact me to go over any questions that you have.